Hello, my name is LJ Anlo and I'm a senior. I decided to work on the Photomosaic option for my final project. So to start off, to kind of like give a brief overview of what the Photomosaic project is, we're given a target photo and a collection of images. In my case, it was a collection of several hundred images I found in a database. And we are going to use the collection of images to recreate the target photo as a photomosaic. So we're going to try and make a photomosaic that noticeably resembles that target photo as much as possible, while still using a variety of those images from the collection, and ideally doesn't cheat the look by having an overlay of the original image. So in order to do this, this is the algorithm I used. First, I scanned in the image using typical MATLAB scanning methods, and I marked down the height and width so I could use that for this next bullet point, which was setting an arbitrary size for each block, then actually setting up that size in context of the image itself. So I'm going to need to use that size to split up the block into several smaller, split up the image into several smaller blocks, a grid of blocks that all represent different portions of the image. And I used a cell array to store those. And we're going to need to use these to insert the photomosaic photos. And while doing this, I also stored the average value of each block into another array, so I can use that for step 3. For step 2, I took all those tile images in the collection and I scanned those in. This step took a while because it was, again, several hundred images and I needed to have all of them in there. And that was just a normal list. It didn't need to be 2D because the location doesn't necessarily matter. While I did that, though, I created a separate array that stored the average pixel values of each individual one. One of the big issues I had here when I was doing this project was I had a lot of grayscale images just in the thing I downloaded. I didn't realize that when I downloaded it, but I had to deal with that, and that caused a lot of hiccups in the process. So once you've stored all of those, you can start iterating through each block in that earlier cell array, and find the tile image in your other array that corresponds to the closest pixel average for each block. So you're not going to get it exact to the pixel average, but whatever the number that's closest is, you want to replace it with that. And then you're done and you've got your full image. But then if you don't do an extra step, you might end up with something like this, where everything is the same and it doesn't look like any variety and it kind of looks really weird. So what I ended up doing was I instead of just choosing one, I had a list of the 5 to 6 closest average values, so that I could alternate between them. And I generated a random number during that and picked a random one of those, so it wasn't so there was a lot more variety. And then I would set the block as that image for each one as I iterated through. So it was a different one next to each one. And then I converted that cell array into a matrix, and then we have our result. And so you can see here, there's the target image and its result, same as this one. And there's one of the things you'll notice about these is that they sort of lost a little bit of color in the process. And that was because of that issue I mentioned with a lot of the grayscale images. So these were all of my results. And it worked pretty well. I would avoid the grayscales more. It was kind of hard to find the right size, and it might benefit from some color casting. But I really enjoyed how much I could customize it. It feels very similar to like seeing the artistic results of Homework 5. It fit all sizes of images and had a lot of variety. And the random method worked really well. So I was pretty happy with the overall results, even though it took a lot of time, could use some time optimization, but overall worked really well. So thank you for watching.